Hi there, Kieran and Brianna and Laura. We're just going to continue on today with the work we started yesterday on inverse functions. So there's a few points there which, when you look through, you'll see we've already addressed. The first here, we can see that a function only has an inverse if it is a one-to-one mapping. So what that's really saying is that the inverse of a function will only be a function if that original mapping or that original function was one-to-one. Okay, we looked at that yesterday. We also saw that the graph of the inverse is a reflection of the original graph in the line y equals x. And so it also means that by interchanging our x and y coordinates, that it would lead to the fact that the domain of the inverse function is the same as the range of the function, and here also that the range of the inverse function will be the same as the domain of the function. Now yesterday we only looked at graphing the inverse function. We don't always have to graph it, sometimes we just need to find the rule, and so to do that we apply the same principle. We interchange the x and y variables in the original function, and then we rearrange to make y the subject. So I'll explain that a little more when we look at this first example. And we did see also that we use this special notation for the inverse of the function. So f with the -1, remember, is a notation, not really meaning f to the power of -1. So let's have a look at example 1 that we've got here. So what we've got here in this example is that we need to find the inverse of this function, f of x equals 3x minus 7, where the domain has been specified to be x greater than 2. And then once we've found the inverse function, state the domain and the range of the inverse. So in order to do that, what we're really looking to see to start with is that we are going to let y, rather than f of x, equal 3x minus 7. Now, for this particular question, it's going to help us if we have stated for this original function what the domain and the range is. So we see already that the domain is, let's say, 2 to infinity, okay, x greater than 2. The range, well, we can see that it's a straight line graph, so, and it's got a positive gradient, so it's going to be moving to the right and up as we increase in x values. So the starting value is going to be when x equals 2. So if we replace our x with 2, we'll have 3 times 2 is 6, minus 7 will be -1. So we can see that our range is going to go from -1 through to infinity because it's a positive gradient, and so the actual graph is increasing. Doing that now helps because we'll be able to see that our domain and range will swap for our inverse function. Now to find the actual inverse function, what we do is, as a first step, we say we're interchanging our x and y variables. So what that means is we look at our original function, and instead of having it written as y equals 3x minus 7, we write x equals 3y minus 7. So we literally interchange our x and y variables. And to find the inverse, we now rearrange this and make y the subject. So we're going to add 7 to both sides, so we'll have x plus 7 here now on the left is equal to 3y, and we need y by itself, so we'll divide by the 3. So y will equal x plus 7 divided by 3. we can see that this is going to be a linear function, so it might be best to write it in a slightly different form to that, in terms of writing it like y equals mx plus c. So y will equal 1/3 x, or x over 3, plus 7 over 3. So that is the rule for our inverse. But it says to find the inverse, the proper way to fully define our inverse is to write it with the proper notation. So in other words, the inverse is f negative 1x equals 1/3 x plus 7, excuse me, 7 over 3. And then we can write our domain is going to be x is greater than negative 1. Now, writing it like that is actually the inverse function fully defined. We've got it with its rule, using the appropriate notation, and following it up with the domain. I mean, in this particular question, it just says find the inverse of the function and state the domain and range. Well, that's fine. The domain's there, but in terms of stating it, the domain is negative 1 to infinity, okay, because it's the range of the original, and the range of the inverse is going to be the domain of the original, so it's from 2 to infinity. So that's example 1. We'll skip example 2 because we did enough of those yesterday in terms of sketching the inverse, but we'll have a look at example 3. Now, this particular function that we have here, that we need to find the inverse for, is not a function that we're familiar with. It kind of looks like it might be a hyperbola sort of thing, but it's not. But it doesn't really matter. For the exercise of what we're trying to do, we can still find the inverse of this particular function. We're given here the particular restriction on this, which is quite clear. When we look at this function here, the denominator is 3 minus x, and because, as we've dealt with before, we cannot divide by 0, so the value of x being equal to 3 would mean that the denominator would become 0. So that's why this restriction is put on here. Okay, so let's go through the same process of finding the inverse. So we're going to let y equal x plus 6 over 3 minus x, and then we're going to interchange our x and y variables so that we actually have written x equals y plus 6 over 3 minus y. Now, to make y the subject, we need to first of all multiply both sides by 3 minus y. So we have x times 3 minus y equals y plus 6. And we're going to have to expand here, so we're left with 3x minus xy equals y plus 6. In order to make y the subject, we're going to have to get all of our y terms over to the one side and all other terms over to the other. So if I bring this y term here over to the left, okay, or actually, given that this is negative here, if I bring that over the left, it'll make me have 2 negatives there. It might be easier if I bring this one over to the right. So I end up with 3x equals y plus xy, okay, plus 6. And now I can bring my 6 over to the other side. So we'll have 3x minus 6 over the left now equals, what I might do is just swap them around, xy plus y. And now in order to get y on its own, we can see we've got two terms here with y in it. So what I'm going to do is take the y out here as a common factor. So 3x minus 6 on the left, and then we're left with y outside of x plus 1. Okay, it wouldn't matter if you had it as 1 plus x. Okay, same thing. Because now you can see we've just got a single y here, which is what we want. And so we're going to divide both sides by x plus 1, because it's y times the x plus 1 in brackets. So if I divide both sides by x plus 1, we'll end up with y equals 3x minus 6 over x plus 1. And that is actually the rule for our inverse. So that means we can write f negative 1, so our inverse function is equal to 3x minus 6 over x plus 1. Now we're not asked to find the domain and range, but to fully define our inverse we need to write what our domain is. And we can see, even though we didn't know what the range is here, we can see from this that there is a particular restriction. We need to make sure our denominator here is not equal to 0. So our restriction would be, our domain must be that x is not equal to negative 1. Okay, so that is our inverse function, fully defined.